Hey guys, so this is what we've done, and we are going to do the pangram. So go ahead and read this here. So essentially, a pangram is a sentence that contains all the letters in the alphabet. Okay, the quick brown fox jumps over the lazy dog is an anagram, a pangram, sorry. So it contains every letter in the alphabet. So our test is going to basically check for pangrams. So let's not git clone, just download this. All right, and go ahead and cd into it. I'm going to open mine up in Sublime. Okay. All right, so here is the test. We're checking that this is a pangram and it will return true if it is. So this is A to Z, so it returns true. So this is another pangram, so it returns true. So essentially we are checking a sentence, and if it's a pangram, it returns true, and if it's not, it returns false. So how are we going to do this? So I was thinking about this one. Let me explain something that I came across when I was doing the research. So there is, what I was expecting is to get all the strings, the alphabets. So we have in a string class, we have the ASCII letters. We can also get them in a lowercase, so I'm going to do that. So it's a string dot ASCII lowercase. So that gives me A to Z. So I don't need to worry about that. So I've got that. And I'm going to save this into a variable called A. So when I go into A will give me A to Z. Alright, so now I'm going to find a sample. I'm going to copy this here because I know this is a pangram. Copy that, and I'm going to save that into a variable called B. Alright, so, and that will give us this. So all I want to do now is say A minus B, right? Because that I was hoping would give me what I need, but that wasn't going to happen. But I discovered if I make A into a set and I make B into a set, I can now say A is that, all right, and B is that, and I can say A minus B. Voila. So this gives me nothing, which means that everything in A was taken away. So let me make this explain this with an easier data. So we have a set ABC, and I said that set minus another set, which is A and B. This would take away A and B, and C will be left. So this is not a pangram, right? But if we had both of them like that, then this is a pangram because everything on the left side is deducted. So that's what I want to use to solve this problem. So if I go into my code, I want to first import a string, and then here I can say something like return set string ASCII lowercase. So this will give me convert all the alphabets into sets, and then I will do the same with the sentence, and also make sure the sentence is all lower as well. Alright, so now this would give me an empty set. If you remember when we had Python here and we had that. Alright, so it gave us an empty set. But I can wrap this empty set with a bool for boolean, and it will be false. So if we have an empty set is false, but if we have content in it, it's true. Alright, so if it's empty is false, content true. In this case, if I wrap this and it's empty, it will return false. Alright, but I want it to return true when it's empty, so I can say something like if it's not empty. Alright, so if I put here not, that would negate or reverse the empty into true. So this would basically work for our anagram. So if it's empty, it will say true, it's anagram. Pangram. I keep saying anagram. Pangram. So there we go. So we have our pangram. And so this is a pangram, and this is not. And our test was able to pick that up. All right, so this here, take away that, gives us nothing, which will return false. Okay, using not would then basically make false into true. So whenever it's false, it'll be true. Whenever it's true, it'll be false. So it's not the most easiest to read. So let's have a look. Let me submit this. Pangram pi. Alright, so let's have a look and see how other people have done this. First, we need to refresh this page and see if it has been approved. Look at that, it was automatically approved. Okay, submit. Actually, this is it. This is where we, yep. So that's it. That's our solution there. Make sure all is there. We can now go ahead and view other people's solutions. So this is what someone else has done. So they basically have the alphabets in there, and then for every character in the sentence, they compare that character to a character in the alphabet, change it to a lowercase, and then if it's not used, they append it to a variable called used chars, and then they'll keep checking, and then in the end they check to make sure that the used characters are equal to 26, which is the total number of the alphabets in English. Alright, so that makes sense. So this one here is saying every letter in the alphabet, so it's like the reverse. It takes the letter in the alphabet, it checks to see if the letter exists in the sentence, and because they're 26, if it doesn't add up, then it will basically fail. So that is also a cool way of doing it, and it's actually very readable. So if it's not in the lower, then you go ahead and break. So that's actually really, really cool. Alright, so now let's see more. So this is actually a very good way of learning what people have done. So in this one here, for every character in the sentence, they check if the character is an alphabet, and then make it into a lowercase, and then check if it is not already used, and they have count plus equals 1 increment, and if it's not used, you go ahead and you make it into a used one, and again at the end they check to see if the count is 26. Okay, so that's very similar to the previous one. And this one has all the alphabets listed, and then you go through the sentences in lowercase, and then okay, it's very similar again, basically, you know, comparing each letter with the alphabets, and then yeah. So go ahead and read this. It's a very good way of seeing how different people come to the same sort of answer. So that's this one done. That's how we did it. It might be tricky to read, or maybe it's not, but it works. It does what I expect it to do. That's it for this one, guys. I'll see you in the next challenge, and we'll keep learning Python. See you there.